I welcome you to our continuation of precipitation of hydroxides, and specifically what we want to see here is the precipitation of colored hydroxides from what we are dealing with as precipitation reactions. The objectives will remain the same. Someone must be able to state the observations made and then predict the products of the reaction, and at the same time write the ionic equation of the reaction. So, like I've said, we are going to see the precipitation of colored hydroxides. The salts we have picked for use, there is copper 2 chloride. That's the salt we have, copper 2 chloride. We have the salt of iron 2. We also have another salt of iron 3. And then our water for dissolving, plus the sodium hydroxide. What is the purpose of the salt when it goes to solution? The salt, for example, copper 2 chloride, when it goes to solution, it will generate for us the cation, which is a key reactant. And that is copper 2 plus, that will give us. Then the iron 2, from what we are seeing here, will give us iron 2 plus cation. Then the iron 3 will give us the iron 3 plus cation. Those are the things that will come out. Let us do the practical part of it and see what takes place. We have already come up with our copper 2 chloride salt solution. We want to see if it meets sodium hydroxide, what takes place. We pick a smaller amount of the salt solution, that is what we have, and then we add sodium hydroxide. Dropwise, what do we see? We see a solid substance coming up, which is still blue in color. So, because it's a solid substance formed from solution, we come up to say that it is a precipitate. So, if you add excess, still it remains as a precipitate. So we get to see that this is a precipitate that is insoluble in excess sodium hydroxide. So from what we have seen there, the dropwise addition to this salt that has copper 2 ions, what comes out is, on dropwise, it is a blue precipitate. That is what it gives us. And in the excess, we see that it gives us something that is insoluble in the excess. Let us see the iron 2 salt. The iron 2 salt is here. When we add some water, dissolve it. So you should always take note. Iron 2, if exposed, will always be oxidized to iron 3. If you leave it exposed for some good time, it always goes to iron 3. So we pick a small amount of what we want. This is the iron 2. Dropwise addition, we see something that is dark, sort of dirty, but it is green in color. So that is a precipitate that has been formed. Dropwise addition, when we try to add excess, nothing changes. That precipitate remains, but when it is extremely dirty in color. So we come and report that this one gives us a dirty green. I want to write green precipitate. So we have the green precipitate on dropwise addition. But even in the excess, it is what? Insoluble, from what we have seen. The last one is the iron 3 salt. We pick a small amount. This is the iron 3 salt. Yellow, pale yellow in color. That's some of the solution. So that is our summer test solution that we have. We pick sodium hydroxide, add drops. When you add drops, you see a browny solid substance formed out. But if you still try to add excess, nothing changes. It is not a solution, take note, because of the solid particles, the brown solid particles that are present in what we have formed. So what do we report? We get to report that when iron 3 or iron 3 salt meets sodium hydroxide, we come up with a brown precipitate. That is on dropwise addition. Then if you add excess, nothing dissolves, so it becomes insoluble in excess. So objective 1 must be able to be realized in this. State what is observed when sodium hydroxide meets either of these salts. Copper 2 chloride, what is observed? Blue precipitate that is insoluble in excess. If we see iron 2 sulfate salts added, we see green precipitate that is insoluble in excess. We see iron 3 sulfate salt added or mixed with sodium hydroxide, we shall see a brown precipitate insoluble in excess. So the objective number 1 must be realized from what we have done. Step 2, predict the products of the reaction and at the same time write the ionic equation. We shall pick this one, the first salt. What did we combine? We brought copper to chloride solution, and we added it to sodium hydroxide solution. We predict our products of the reaction like we did in our first discussion. Simply come and look at this, split it. When you split it, this one gives you the positive side of what we are dealing with, which is the copper 2 plus. This one gives you the negative side of what we are dealing with, which is the chloride in solution. And that is it. But there are how many? 2 chloride ions. Come and split this. When you split it, what does it give you? It gives us the sodium plus in the solution. It also gives us the other side, this negative side, which gives us the radical of the hydroxide in solution. That is what we have. Predict the possible products that can come out. This one is a positive. It has been existing with this. These two cannot combine. So what can combine? This is also positive. This is also positive. Metal, they cannot combine. So the first possible combination that can come out is us having this combined with the what? The hydroxide radical. So we come and show that we have this possible combination, which is this with that. If these two combine in solution automatically, what remains behind will also combine to give us a product that combining with that. Next step, if I've seen that I can predict the products, can I write the formula of those products? Because copper is coming to meet this hydroxide radical. Let us try it out here and see. If copper meets the hydroxide radical, let us come up with the formula of what we get. Copper is from this, the valence is 2. Then this side, the hydroxide, from what we are getting, the valence is what? 1. So interchange and see from our format of writing chemical formula of compounds. This one gives us the copper hydroxide, which is of that type. That is the formula. This is what is appearing as the blue precipitate that we have recorded here. So we come and bring our first product. We put it here as the copper 2 hydroxide. It is a solid because it's a precipitate. A precipitate will always be given the solid state as we write those equations. We erase this and then come up with the second what? Compound. The second compound is formed from this and that. So from this and that, what do we come up with? We come and write the formula of the compound. The sodium, from what we are seeing here, the valence is 1. Then the chloride, the valence is also what? 1. So if you interchanging gives us the formula of the compound as sodium chloride in this format. This one is appearing in solution. So it is an aqueous salt formed at the end of it all. So this is sodium chloride, and that is what we have as aqueous. We erase this. Next is from that, whatever you have formed this as the part of your products must help you balance the equation before we bring in our last step of writing the ionic what? Of writing the ionic equation. So let us balance out the equation of the reaction from the products we have formed the other side. Copper is 1, even this side copper is 1, so that copper balances. We have 2 chlorine atoms or 2 chlorides. This side we have on the 1. So we interchange the factors. This 2 must come this side, and then the one coming this side doesn't change anything. So it is only picking the 2 and bringing it here. That 2 is not put here. That 2 is not put in between here, but it is put as a coefficient to multiply out that. Because it will work for sodium, at the same time it will also work for the chlorine. So the chlorine balance is out. Next is sodium. Sodium, this side is 1. This side, the sodium is what? 2. So pick this 2 and bring it this side, which gives us that. So the sodium has also balanced. However, this 2 coming here means it is also coming to serve the whole of this hydroxide radical. So the 2 multiplies the whole of that hydroxide radical. So how many hydroxide radicals do we have this side? There are 2 hydroxide radicals. You pick these 2 and you multiply it with the whole of the hydroxide. So there are 2 hydroxide radicals this side. Then if you look at this side, the product side, the hydroxide radicals are also what? 2. So the equation balances out. That is the next step prior to writing our ionic equation. So the last thing that we do is to come up with the ionic equation of the reaction. And the ionic equation of the reaction will be, we break up the reactants into ions, at the same time the products into ions. Then afterwards, we remove what we call spectator ions and write the equation only showing what exactly has participated in the reaction. However, what do we note as we write the ionic equation? Whatever is aqueous will separate with us ions. Then whatever is a solid will remain as a solid substance. Whatever is a liquid remains as a liquid. And whatever is a gas remains as a what? As a gas. So we look through this and you see, this is aqueous, it separates with us ions, just the way it is here. This is aqueous, so it separates with us ions, just the way it is here. This one is a solid substance, nothing will take place, so it will remain the way it is. And this is aqueous, therefore it will separate with us what? Ions. So our next step is to write those ions. But recall we have balanced. The new cause of balancing, and us putting here a 2, it means these sodium ions are 2 in solution. The same time, this 2 works for the hydroxide as we have said. Therefore, the 2 will also come and be used at that. So these are the ions for the reactant side. Then also, we come and split this. This will not split, but we split this and it gives us the ions of what we want. So from what we are seeing, we have 2 sodium ions. At the same time, we have the 2 chloride ions. So that is all in solution. That is in solution. We have said this one remains as a solid, so it will be copper 2 hydroxide in solid state. Let us outline everything the way it is in terms of the ions. So we bring copper 2 ions in solution plus the 2 chloride ions in solution plus the 2 sodium ions in solution plus the 2 hydroxide ions in solution. The reactant side is finished. We got the product side. We bring this the way it is because we have agreed that a solid substance remains as a solid plus these are 2 sodium ions. So we bring they are in solution plus the 2 chloride ions. They are also in what? Solution. Next step, we cancel out the spectator ions that are present. Spectator ions will mean those ions that are not participating in the reaction. They appear on the reactant side, they also appear on the product side. So the copper 2 plus, we begin with this. Copper 2 plus is this side. Does it appear the other side? It is not anywhere to be seen. So copper 2 plus remains. We come to 2 chloride ions. 2 chloride ions on the reactant side. Do we see any 2 chloride ions on the product side? Yes, it is, and that's where it is. So this one cancels out. Why? Because it is a spectator ion, it is not participating anywhere. It is on either sides. Next, we have the 2 sodium this side of the reactants. We have 2 sodium on the side of the products. Therefore, this one appears to the spectator ions because it's appearing this side, at the same time it is appearing the other side. So it cancels out. We see the hydroxide ion appearing anywhere the other side. It is not. Don't confuse it with this because this is intact. It is locked up. It is not separate as this. So because it does not appear there, that's where we end. Then we come and outline the net equation of what has remained. So we are seeing we have the copper 2 plus has remained copper 2 plus aqueous, we see the 2 hydroxide what? Ions present, appearing to give us, on reaction, they give us copper 2 hydroxide, which is that. So this appears to be our ionic equation for the reaction. And that is how we come up with our third objective of writing the ionic equation for the reaction. So based on this, let someone come up using the same criteria. Write the ionic equation for the reaction that takes place when we see iron 2 sulfates combined with sodium hydroxide. Write that one, try it out. Then try out the ionic equation for iron 3 sulfate combining with sodium hydroxide. Just following those steps, I'm very sure things will be able to come out. And that is the end of our discussion in terms of precipitation of hydroxide.